Welcome to Comfort Learn classes. In this series of videos, I will solve previous year questions, NCERT important questions, and few questions from the sample papers from the chapter Continuity and Differentiability from PU second year. If you have any specific questions to be solved, either from some reference or from NCERT, you can just put it in the comment section. Let's start with the first question. F of x is mod of x plus 3 if x is less than or equal to minus 3, and it is minus 2x if x is between minus 3 and then 3, and if it is 6 plus 2 if x is greater than 3. Now we need to check for the continuity of the function, or we need to find the points where the function is discontinuous. So again, let me start with the region. So what are the input values, or how the function is changing? What we have here, we have minus 3, we have 3 here, right? So now if x is less than or equal to minus 3, less than or equal to minus 3, that is including minus 3, the value of the function is mod x plus 3, right? And between minus 3 and 3, right, excluding minus 3 and 3, just between these two, right, the value of the function is minus 2x. And if x is greater than or equal to, that is including greater than or equal to 3, then the value of the function is 6x plus 2, right? So this is how the function is defined. Now we need to check for the continuity. Again, the flow of the solution will remain same. First we need to take a regions, first region, second region, and then third region, right? So that is for x less than minus 3, the value of the function f of x is equal to mod of x plus 3, right? And we know what is mod of x. X if x is greater than or equal to 0, minus x if x is less than 0. So now here x is a negative number, so you can directly take it as minus x plus 3. So this is our f of x. And what is minus x plus 3? It is a polynomial expression. So f of x is continuous for all the x less than minus 3, as f of x is polynomial. It is continuous. It is continuous for this range, that is x is less than minus 3. Now we are done with the first region. Second region, that is for x less than 3 or greater than minus 3. The f of x is minus 2x. Again, minus 2x is a polynomial, so it is continuous. You write the same here, right? So now we got for the second region, and then for x greater than 3, that is for the third region. Again, f of x is what? The f of x, or the function, is 6x plus 2, which is again a polynomial, right? So write the same here, right? For all the three regions, we have three different polynomial expressions, hence they are continuous. So once you are done with the region, you need to take a specific points now, because at x is equal to minus 3, the function is changing. At x is equal to 3, again the function is changing. So now let me take x is equal to at x is equal to minus 3. Let me check the continuity of the function at x is equal to minus 3. For that, you need to show LHL, RHL is equal to f of x. So let me take first f of x, that is f of minus 3. And what is f of minus 3? When x is equal to minus 3, mod of x plus 3. And what is mod of minus 3? Mod of minus 3 is 3 plus 3, which is equal to 6. So the f of x, we got 6 here. Now let me find LHL, that is left hand limit, that is limit x tends to minus 3. So left hand limit, we are approaching it from left hand side, so you need to take a negative sign here. For left hand limit, take a negative sign. So this negative sign indicates the input value is less than minus 3. The input value is less than minus 3 or we are approaching minus 3 from the left hand side. Okay, so then if it is less than minus 3, what is the value of the function? Again, mod of x plus 3, mod of x plus 3, right? So again, mod of minus 3, that is 3 plus 3 is equal to 6. That is our LHL. Now we need to find the RHL. Now what is RHL? Limit x tends to minus 3 plus from this side, right? So what is minus 3 plus? Greater than minus 3. If x is greater than minus 3, then minus 2x, minus 2, and x is again minus 3 here, so which is equal to 6. So now you can see minus 6, 6, and then 6. LHL, RHL, and f of x, all the three are same. F is continuous. So now take the next point at x is equal to 3. At x is equal to 3, again same LHL, RHL, and f of x. What is f of x? That is f of 3, right? So what is f of 3 here? And x is equal to 3, the value of the function is 6x plus 2, or 6 into 3 plus 2, that is 20. And LHL limit x tends to 3 negative. 3 negative is x is less than 3. From here, x is less than 3, minus 2x minus 2 into x is 3 here, minus 6. Okay. RHL limit x tends to 3 plus from this side. So x is this side, x is greater than 3, x is greater than 3, 6x plus 2, right? So then 6x plus 2, or 6 into 3 plus 2, which is equal to 20. Fine. So now here LHL we got minus 6 and RHL we got 20, right? So LHL is not equal to RHL, hence f is not continuous. F is not continuous at x is equal to 3, right? So the function is not continuous at x is equal to this point 3 here, right? So other than that, it is continuous. First region, second region, third region, and even at x is equal to minus 3, we got LHL, RHL, and f of x same. So it is continuous. So only point of discontinuity is x is equal to 3 here. The only point of discontinuity is x is equal to 3. Okay. Fine. Discuss the continuity of the function. F of x is 3, 4, and 5. The function f is having 3 different values, okay, for the 3 different inputs. So for x greater than or equal to 0 and less than or equal to 1, the value is 3. For x greater than 1 and then less than 3, 4. And for x greater than or equal to 3 and then less than or equal to 10, 5. So now if I put a number line here, so here we have, let me take 0, and then 1, and then 3, and then 10, right? First let's get the regions here. So here for x greater than 0, greater than or equal to 0, and then less than or equal to 1, right? For this input, the value of the function is 3. And for greater than 1, that is excluding 1, and then less than 3, again excluding 3, the value of the function is 4. Next, for greater than or equal to 3 and less than or equal to 10, the value of the function is 5, right? So now this is how the function is defined. Now we need to check the continuity, or we need to find the points of discontinuity for the given function, right? So now the flow of the solution will be same. First you check the continuity of the function for different regions and then take the specific points. So now let me start with for x less than 1 and greater than 3. Okay, the first region less than 1 and then greater than 0. So for this range of input values, the value of the function f of x is 3, right? And it is a constant, and constant function is always continuous function. So as f of x or the function as f of x or the function is a constant or a constant function, it is continuous. Okay. Next, second region, that is 4. We are done with the first region. Let me take the second one. Greater than 1, less than 3. For x greater than 1 and then less than 3, f of x is 4. Okay. So again, the function is constant. So we just write the same sentence here. As f of x is a constant, it is a continuous function. So let me take the third region for x greater than 3 and then less than 10, right? So for x greater than 3 and then less than 10, the f of x is 5, right? So again, constant function, take the same sentence, right? So now the function is continuous for all the three regions, region 1, region 2 and then region 3. So now we are done with the three regions. Now we need to check the continuity of the function at a specific points, that is 0, 1, 3 and then 10, right? So now here let me take the first point 3, that is at x is equal to 1. Let me check the continuity at x is equal to 1. So now here, if you want to check the continuity at a specific point, you need to check LH, L, RH, L and then f of x. If all these three are same, then it is continuous. So left hand limit, that is limit x tends to 1 minus, left hand 1 minus and then f of x. So 1 minus is less than 1. If the function is less than 1, then the value of the function is 3. Similarly, you find the RHL, that is limit x tends to 1 plus is greater than 1. If the function is greater than 1, then the value of the function is 4, right? If it is less than 1, it is 3 and greater than 1, it is 4. And what about f of 1 or f of x, that is f of 1? When x is 1, the value of the function is 3. So here you can clearly see this LHL is 3 and then RHL is 4, right? So now LHL is not equal to RHL. Okay, hence the function is not continuous at x is equal to 1. You can read a sentence here. It is not continuous, okay, at x is equal to 1. So let me take the next point. So what is the next point here? At x is equal to 3. Let me check for 3. So LHL limit x tends to 3 minus less than 3, then the value of the function f of x will be equal to 4. RHL limit x tends to 3 plus, that is greater than 3, the value of the function is 5. No need to check for f of 3, as LHL is not equal to RHL. As LHL is not equal to RHL, the given function, it is not continuous. Okay, fine. So now see, you can't take 0 and then 1 because the function is not defined for less than 0. See here, what is the range? It starts from 0. The function is not defined for less than 0, neither it is defined for greater than 10. So now you can't find the continuity of the function at 0 and then 1, these 2 points. Okay, so that's why we need to take 1, 3 and all the 3 regions, right? So it is continuous in the region, but it is not continuous at x is equal to 1 and x is equal to 3. So what are the points of discontinuity here? The points of discontinuity. Points of discontinuity, x is equal to 1 and x is equal to 3. Okay. Find the relationship between a and b so that the function f of x, that is ax plus 1 if x is smaller than or equal to 3, bx plus 3 if x is greater than 3, is continuous at x is equal to 3. So here the function is continuous at x is equal to 3. It is given, right? So the function is continuous at x is equal to 3, and you need to find the relation between a and b, right? So here at x is equal to 3, it is continuous, and as it is continuous, you can directly take LHL is equal to RHL, right? Because the function is continuous. So now you find the LHL, RHL separately and then equate the expressions. So now let me get the LHL, right? So the difference between the previous question and this question is, in the previous question we used to find whether the function is continuous or discontinuous, and if it is discontinuous and at which point the function is discontinuous we used to find. But here it is given that the function is continuous at x is equal to 3, and you are asked to find the relationship between a and b, right? So now first find the LHL. Limit x tends to, that is 3 minus f of x. Limit x tends to 3 minus, that is less than 3. If the value of x is less than 3, then it is ax plus 1. Okay. So now substitute 3. This is not, this negative sign is, it gives just a direction here, right? So you can directly take it as a into 3 plus 1, right? Or you can write 3a plus 1, that is your LHL, right? So we got the LHL. Now similarly you get the RHL. What is RHL here? Limit x tends to 3 plus, right? So that is greater than 3. If x is greater than 3, then the value of the function is bx plus 3. Now substitute the values, that is b into 3 plus 3. So which is equal to 3b plus 3. So that is our RHL. And we know that RHL and then LHL are same. So LHL is equal to RHL. And then what is LHL? 3a plus 1, and RHL is 3b plus 3, right? So now you can simplify this further, and then you will get 3a minus 3b is equal to 3 minus 1, that is 2. So what is the relation? The relation between a and b is 3a minus 3b is equal to 2. Okay. So this is the relation between a and b, and the function is continuous at x is equal to